Hello. If you already know what the experiment's about, you can just jump 6 minutes in and skip all the arguing with Gary. But for those of you who don't know what the argument's about, it might benefit you to just stick around for a minute or so, and then you'll get the gist of what Gary's arguing and why I'm saying he's talking rubbish. This is basically about him claiming that it's not true that it takes 4 times as much energy to get a car to go twice as fast, even though engineers have known this stuff for years. Gary disagrees.
If it was actually true
It is.
that the higher acceleration stole 4 times the energy,
It does.
you don't think this would be a known fact
It is.
and everybody would be driving much slower
No.
and they'd be much more careful about accelerating fast,
No.
doing anything fast,
No.
because anything fast would cost them a huge amount of energy.
Not really, because you get most of it back. Your car moving is stored energy. You can recover most of it. That's why it takes 4 times longer for your car to stop at twice the speed.
I think trying to measure things with an EV would be more reliable than gas engine. And you think in all of this time, nobody's done this simple experiment.
3.2 on the load. Okay.
Nobody's done this simple experiment.
11.7 went on the load.
Nobody's done this simple experiment.
What a stupid statement.
Nobody's done this simple experiment of finding out whether I can make the motor go twice as fast. I can spin it at twice the rotation, and I'll need 4 times as much electricity to do that.
23.9 on the load.
But that wouldn't have been found out by everybody, and they say, whoa, it's hugely inefficient to run a motor fast. So it obviously hasn't been found out by accident.
By accident? Why would it be found out by accident? Do you think people are just stumbling around in the dark, saying, oh, let's just connect this wire to that and see what happens? No, people are doing purposeful experiments.
And I sort of didn't want to.
Idea we're going to procedure and 2 key
They design experiments. They test things in a purposeful, thoughtful, analytical way. They're not as stupid as you. Nobody's as stupid as you.
It isn't something anybody's noticed.
Gary, you are the ultimate conspiracy theorist. You make flat earthers sound rational.
So I'm just saying, if it were actually true.
And of course, nothing can possibly be true unless Gary has given it his stamp of approval.
If it was actually true,
they would have told Gary straight away. They would have made a beeline to his house, made sure that Gary knew before anyone else.
If it was actually true,
it would blow Gary's tiny mind.
If it was actually true,
let's be honest, Gary would be the last person to figure it out. Gary would be the last person to bother finding out. Gary wouldn't even believe it because he's a moron.
If it was actually true that the higher acceleration stole 4 times the energy, twice as much energy.
4 times, twice.
4 times the energy, twice as much energy.
Oh, they're similar, aren't they? Let's not fall out over numbers. Ohms, weight newtons. Newton's weight per pound.
You don't think...
We do think
this would be a known fact.
I'm quite sure it is amongst the people who need to know. You don't need to know.
Everybody would be driving much slower.
Why? It's like saying, oh, don't drive uphill, you'll never get back down again. Have you ever heard of Kerr's kinetic energy recovery system? You don't understand that when you accelerate, you are collecting energy, so to speak. That's why it takes a long time to slow your car down, because you've built up that speed in your car. You're storing energy, in effect. When you accelerate your car to a certain speed, you are accumulating energy like a flywheel. When you spin a flywheel up to some fantastic rate, you are storing energy. It takes a lot of energy to get it up to that rate, but once it's going, it'll maintain that rate quite easily, but it took a lot of energy to get it to that rate in the first place. But now you've done it, the energy is there for you to recover when you need it. Formula One cars use that, or have used that. I think they have used actual flywheels as a kinetic energy recovery system. Don't know if they still do.
They'd be much more careful about accelerating fast up hills.
Not that much, Gary, because you get most of it back. You get most of the energy back because your car is storing it.
Because anything fast would cost them a huge amount of energy.
Oh, and they could never get it back because Gary says so. It would cost them energy, they could never recover it. His stupidity is just shocking.
Shit, they probably have it already built into cars that they couldn't, accelerate too fast.
Have you ever seen how fast the Tesla car accelerates, you moron? Why do you think Porsche are making electric cars, you moron? Sorry about the noises
I
in the
hope the
background.
camera is in a decent position. I don't think it is. I just want to keep recording how many revs this does per voltage. So that same motor I recorded a bit ago from the back, I'm going to record from the front this time. So this time under load. So we have a voltmeter measuring the voltage. That'll switch power on and off to the motor. Start off 1.5 volts. Okay, well technically 1.5 volts, but it'll actually be 1.63, more like 1.64 volts. I'll write that down on my sheet. I'm going to keep a record. So 1.64 volts, no load. Let's just see what happens now. Okay, so it went to 1.60 under load and 1.60 under load. So now let's go to 3.26 volts, no load, and 3.2 under load. Okay. I'm not running these for any particular length of time. Okay, next let's go to 6.48, 6.38 on the load. Okay, I've not been putting this at the beginning ever, never mind. Let's go to the next one. 12.16 volts. 11.7 went under load. .24 volts we're not now. Okay, 24.2, then 23.9 under load. Just in case I didn't start that in the right position, I'll put it back there. Okay, okay, I think that'll do. Down to 4.7 load. Okay. The meter beeped at me. In other words, it was going to cut off a minute. So let's go to the next one. 9.4 under no load. 9.2, say, under load. Okay, 18.79 under no load. Then 18.28 under load. Okay, I think that'll do.
So the green line is what the curve would look like if doubling the voltage doubled the speed under load conditions. 24 volts would be 16 times faster than 1.5 volts, not approximately 5 times faster as shown by the pink curve, which is reality. The reality is doubling the voltage does not result in doubling the speed. Far from it. And even if it did, doubling the voltage also quadruples the power because doubling the voltage generally doubles the amps as well. So amps times voltage equals power, therefore you have 4 times the power requirement. Converting the previous graph to seconds to complete one revolution, the first revolution. So the green curve shows the fantasy of if merely doubling the voltage in amps doubled the speed. It doesn't. So the pink curve shows the reality of how much more voltage and amps, in other words wattage, are needed to accelerate a motor under load to twice the speed in just one revolution. At 1.64 volts, it took 3.42 seconds to complete one revolution, 411 frames at 120 frames per second. Quadrupling the voltage, it took 1.58 seconds, just over double. So a little below that, you can see at 5.5 volts approximately, it would achieve double the speed, 1.7 seconds to do one revolution. So I've done amps in black, volts in red. So I've highlighted the two cases there. At 1.6 volts, it took 3.42 seconds to complete one revolution. At about 5.5 volts, we estimate it would have doubled that speed according to this graph, according to real measurements. It would have doubled that speed to 1.7 seconds to complete one revolution. I'm estimating the current to be 0.6 amps there because of the 0.7 amps at just over that voltage. So that approximately works out to 3.3 watts versus a quarter of a watt. So clearly we're having to put in even more than 4 times the energy to double the speed, to double the acceleration. So clearly we need even more than 4 times the energy to get this thing twice the speed right from the off. In this case, we need more like 12 times the energy. Of course, there's going to be some variation depending on whether we're comparing 1.6 volts to 3.2 volts, or 3.2 volts to 6.4 volts, 12 volts to 24 volts. Of course, things do get complicated. Anyway, the green curve shows the fantasy of merely doubling the energy input to supposedly double the speed output. It fails badly. You can see it fails badly. It just doesn't happen. It's understandable why a person would think it does, but it doesn't. Taking measurements from real motors instead of just guessing what would happen shows the reality, and we have to face reality. It's silly to avoid facing reality because it makes all a person's so-called physics guesses utterly meaningless. It's important that we don't do that. Right, so this is just a record of the ideal voltages that I wanted to repeatedly double to test Gary's dubious claims that doubling energy doubles speed, and you don't have to quadruple the energy input to achieve double speed in line with the kinetic energy formula. So unfortunately, obviously it's not easy to start off with exactly 1.5 volts and then double it to 3, 6, 12, 24. So I've actually started with 1.64 doubled to then they're all approximately doubled.